and welcome everyone to one more lecture of probability and statistics. Today we will learn about central limit theorem and we will learn how to use it to solve some questions. Central limit theorem. Central limit theorem states that, let's say we have x1, x2 to xn. These are independent random variables, and if expectation of xi equals to mu I, mean of xi, ith random variable is mu I, and variance of xi equals to sigma I square, then where I equals to 1 to till n and n tends to infinity, then summation of these random variables Sn equals to x1 plus x2 till xn. Then this is a distribution which follows normal distribution with mean mu equals to sigma I equals to 1 to n mu I, and its variance will be summation I equals to 1 to n sigma I square. So this is our central limit theorem. If we have a sum of independent random variables, then this distribution will follow normal distribution with mean value equal to summation of every mean value and variance equals to summation of individual variance. And if, let's say, expectation of every random variable is mu and variance for every random variable equals to sigma square, then this will follow a normal distribution. Sn will follow a normal distribution with mean mu equals to, mean will be n times mu and variance will be sigma square by n. Now, how these are derived? If we will do summation of this, our mean will be summation mu, and this will be I equals to 1 to n, and every mean value is mu only, so this will be equal to n mu, and similarly our variance will be equal to n sigma square. If Sn equals to 1 by n times x1 plus x2 till xn, and mean value for every random variable is mu and variance for every random variable is sigma square, then this Sn will follow normal distribution with mean mu equals to n times mu divided by n. This will be equal to mu only. So our mean will remain mu and our variance will be n times sigma square divided by n square, that is sigma square by n. This is our variance. So this Sn, which is 1 by n times summation of every random variable, this will have a mean that is equal to mean of these random variables, and variance will be sigma square by n, and standard deviation sigma will be sigma by root n. So this is our central limit theorem. Now we will solve a question based on central limit theorem, so we can know how to use it. Our question is, an electric firm manufactures light bulbs that have a life that is normally distributed with mean equals to 80 hours and a standard deviation of 40 hours. Find probability that a random sample of 16 bulbs will have an average life less than 775 hours, and we have given this probability. Now, so this is 800. This sample of 16 bulbs will follow approximating normal distribution. And as we know, normal distribution have two parameters, its mean value and its standard deviation. Now, if our new x random variable is defining average life of these 16 bulbs, then our mean value will be 800 hours and our standard deviation, new standard deviation will be sigma, initial sigma divided by root n. So this will be 40 divided by root 16, that is 40 divided by 4, and that equals to 10 hours. Now we have to find out probability of x. Let's say if x random variable is defining average life of these 16 bulbs, then it should be less than 775. Now we have this in form of normal variate, but we have probability in the form of standard normal variate. So we will change this in standard normal variate. So this will be equal to probability of z less than z equals to x minus mu divided by sigma. So this will be x 775 minus mu 800 divided by 10. So this will be equal to minus 25 by 10, that is minus 2.5. Now if we will draw the graph, let's say this is our graph of standard normal variate. This is symmetric about its mean value, and let's say here somewhere is point minus 2.5 and here is point 2.5. Then we have to find out this probability, and we are given with this probability. Now as we know, the area under the graph, like the whole graph, is 1, and this graph is symmetric about z equal to 0. So this whole area will be 0.5, and we know that this area and this area are equal. So this, if we can find out this area, then that will be our answer. So this area will be 0.5 minus this area that is given to us. So this will be 0.5 minus 0.4938. So this will be 10 minus 8, 2, 9 minus 3, 6, 9 minus 9, 0, 4 minus 4, 0. So this will be 0.0062. This is our answer. Our next question is, if x1, x2 to xn are Poisson varied with parameter lambda equals to 2. We have to use CLT to estimate probability of 120 less than equal to Sn less than equal to 160, where Sn is summation of x1 till xn and n is 75. Now we know that in a Poisson variable, for a Poisson random variable, mean equals to lambda equals to variance. Mean and variance both are lambda, which is parameter of Poisson Poisson distribution. So EXI, the EX mean value equals to 2 and variance of x also equals to 2. And as we know that if Sn is summation of individual x random variables, then this will follow a normal distribution with mu mean value equals to n times mean value of these random variables, and sigma standard deviation will be under root n times sigma of xi, these xi's. So this will be n into 2, so this will be 75 into 2, 150, and this will be equal to under root 75 into sigma, this is sigma square, into under root 2. So this will be under root 150. Now we have to find out probability of 120 less than equal to Sn less than equal to 160. Now this is in the form of Sn and this is in the form of Z. If we will turn this in the form of Z, so this will be equal to 120 minus 150 divided by under root 150. 120 minus 150 divided by under root 150. So this will be equal to minus 30 divided by 150, and this will be equal to 160 minus 150 divided by under root 150. This is 10 by under root 150. If we will solve these two values, this will be equal to minus 2.45 less than equal to Sn less than equal to 0.82. Now we have to find out probability of this interval. If we will draw the graph of standard normal variate, which is symmetric about mean value, which is z equals to 0, here will be point minus 2.45 and here somewhere will be 0.82. So we are given with the probability of this probability, that is 0.2939, and if here is 2.45, then this whole probability, which is 0.4929. Now we have to find probability of this interval, and if we will just draw this graph for 2.45 plus minus, this will be minus 2.45 here, 0, 2.45. And as we know, this graph is symmetric about 0. So this area will be equal to this area. So this probability will be equal to probability of minus 2.45 less than z less than 0. So we have probability of this area till 0.82 and probability of this area, and we have to find out this probability. So we will just do summation of these. So our answer will be equal to probability of minus 2.45 less than z less than 0 plus probability of 0 z 0.82. Now this equals to this, so this will be 0.4929 plus 0.2939. Our answer will be 998, 3 and 3, 6, 9, 9, 8 again, 4, 2 and 1. 0.7868. This is our probability of this interval and this is our answer. That's all. We will meet in our next lecture.